Hey guys, last section in 6.3, we are talking about explicit formulas for sequences this time. So we're going to start out kind of the same way we've been doing things. So here's a sequence. First question, is this arithmetic or geometric, and why? Well, we've got to figure out our pattern. Our pattern here is well, to get from 18 to 22, I could add 4. From 22 to 26, I could add 4, and 26 to 30, so it looks like I'm adding 4 every time. If you are adding a constant number, we know from section 6.2, that makes it arithmetic. So I would say it is arithmetic because we are adding a constant number. Part B, what's the 100th term in the sequence? Whoa, 100. Okay. All right, I want you guys to pause the video and find the 100th term. Come on, pause the video. Okay, hopefully you guys found what you think is the 100th term. And what would you have to do? You just have to keep adding 4 until you got to the 100th term. Right? That's how you would explain what you did. But I want to find an easier way because that is a lot of work and it'd be really easy to make a mistake and accidentally hit +4 too many times or not enough times or lose track of where you are. It's just, that's not going to be fun to do. So let's think about what we did. We had our, let's make a t-chart. We have our n, that's our number term, and then our a sub n is what the term actually is. So our first term was 18, our second term 22, third term 26, and our fourth term 30. Let me make another column here. Let me think about what I did here. Well, I know to get the 22, let me make that a solid line so we don't get confused. I know to get the 22, I took 18 and I added 4. And to get the 26, I took 22 and added 4. But really, another way to think of it is to get the 26, I started with 18 and I added 4 2 times. I started with 18 and I added 4 2 times. To get the 30 then, following that pattern, I took the 18 and I added 4 1, 2, 3 times. Okay, so going back up now, we could fill what number in right here? How many times did you add 4 to get the 22? Just one time. And up here, if we wanted to follow the same pattern, well, we know we're starting with 18. How many times did you add 4 to get 18? None at all. And you can see that your numbers 3, 2, 1, 0, 0, 1, 2, 3. Oh, that's neat. Okay. So definitely I'm seeing a pattern emerge here, right? So think about it. We want to find the 100th term. So our n would be 100. We don't know what that is. We're trying to find it. But let's follow the pattern. We're always starting with 18, and we're always adding 4. It's just a matter of how many times are we going to add 4. Well, if you compare these numbers to the n's, what do you notice? The number you're multiplying by is always 1 less than your n. 3 is 1 less than 4. 2 is 1 less than 3. 1 is 1 less than 2. 0 is 1 less than 1. So this isn't going to be n, it's going to be n minus 1. But in this case, our n is 100. So what number should be there? A 99. Okay, so let's calculate that. 18 plus 4 times 99 is 414. Is that what you got when you just sat there adding 4? Hopefully. 414 is the correct answer. Okay, so that's a way easier way to do it. So what we have here, what we came up with, is an explicit formula. An explicit formula is a formula that generates any term in the sequence. Okay, so think about what we learned in the last section. We learned about recursive formulas. An explicit formula explicitly tells you what the answer is going to be. You don't need anything well, I'll show you what you're going to need. But with a recursive formula, you have to think of what's the number before it, what's the number before it, what's the number before it. So you need that recurrence of the term in front of it. Explicit formulas, you don't have to know the term before it. So to find the 100th term, I didn't have to find the 99th and the 98th and the 97th and the 96th. I was able to just jump from the 4th term all the way to the 100th. So you can see how much time and work you would be able to save in doing that. Here is the general form for the arithmetic explicit formula. So this is only for arithmetic, which is what we just had back here. It is I wish I could cover all that. A sub n, so whatever you're looking for, take your first term, add d times n minus 1. What's d? D is the common difference. So in this problem back here, it was 4. It's whatever you're adding each time. Okay? N is the term number. And you can actually simplify it to turn it into slope-intercept form. Okay, so if we go back to this problem, let me copy and paste this. Oops, not that far. Okay, so a sub n is going to stay a sub n. And sometimes you see it lowercase, sometimes you see it uppercase, that doesn't matter. Okay, a sub 1 in our sequence is 18 plus d is 4 times n minus 1. So that would be the specific explicit formula for this problem. And you can see that's what we used. So when we were finding 100, we were looking for a sub 100, the 100th term, and we knew that was equal to 18 plus 4 times our n was 100, so n minus 1 is 99. That's exactly what we calculated. And that gave us the answer of 414. So a sub 100, the 100th term, is 414. To rearrange it into slope-intercept form, you would need to do distributive property. You would be distributing the 4. So 4n minus 4. And then combine like terms, 18 and negative 4 is 14 plus 4n. And then finally you could rearrange that order because we wanted mx plus b. Okay, n being your x in this case. All right, neato. Let's try another one. Consider this sequence. 4, 12, 36, 108. Is it arithmetic or geometric? Well, as soon as I see that my number starts getting pretty big pretty quickly, I'm going to think geometric. So let's see. Are we multiplying by 3 on this one, by 3 here, and by 3 here? So yep, that's geometric. Why is it geometric? Because we're multiplying by a constant each time. What's the 25th term? Okay, so certainly we could hit times 3 times 3 times 3 times 3 until we get to the 25th term, or we can look for an explicit formula. Now keep in mind, the formula I gave you back here is arithmetic only. So let's see if we can come up with a geometric one. So let's make another t-chart. N1, the first term is 4. N is 2, the second term gives you 12. Third term, 36. And the fourth term, 108. Okay, and let's do a third column where we're trying to figure out a formula. So it looks like what we do is we always start with 4. So here we started with 4, and it was just by itself. Here we started with 4, and we had to multiply it by 3. Now, of course, you could think of 36 as being 12 times 3, or you could think of 36 as being 4 times 3 times 3. So 4 times 3 times 3. What's another way to write 3 times 3? 3 squared, right? You could use exponents. So 4 times 3 to the second power. 108, you start with 4. How many times did you multiply by 3? 1, 2, 3. So 4 times 3 to the third power. So we're seeing a pattern. Let's fill in some extra numbers. 3, 2, this was 3 to the first power. This one we didn't have to multiply by 3 at all, but you could also just follow this pattern, 3, 2, 1, 0, and keep in mind that any number to the 0 power is 1, so this would be an accurate representation. Okay, we want the 25th term. So n is 25. We have to solve for a sub n. Well, follow the pattern. It looks like we start with 4. We multiply it by 3. And then take a look at your numbers again. Your exponent is 1 less than your n. So to find the 25th term, we would have to do it 4 times 3 to the 24th power. Plugging that in my calculator. I get a really big number. So big it's actually in scientific notation. So I'm not worried about you writing it down. The best way to represent it is going to be in this form. Okay, so let's come up with the explicit formula. So it looks like to find a sub n, we take a sub 1, our first term, and we were multiplying it times, well, we're not going to call it a common difference, because difference kind of refers to addition and subtraction. We're going to call it a common ratio. So we're going to call it R. And we take it to the n minus 1. So here it is. General form for the geometric explicit formula, a sub n equals a sub 1 times r to the n minus 1, where r is the common ratio, which is the number you're multiplying by to get from one term to the other, and n is your term number. So again, you can see how much easier, or how much quicker, I guess, it would be to use the explicit formula versus the recursive, because instead of having to keep finding every single term to get to the 25th, we could skip from the 4th all the way to the 25th, okay, without finding the ones in between. Example 3, new sequence, arithmetic or geometric. Looks like it might be arithmetic. Let's try it. So what do I have to add to get from 100 to 83? Well, I'm actually going to subtract 17, which is really adding a negative 17, okay? 83 minus 17 again to get to the 66. And just to double check, yep, it is minus 17 to get to the 49. That makes it arithmetic because you're adding a common number each time. It just happens to be a negative number. So we have to think about our formula for our explicit formula for arithmetic. A sub n equals a sub 1 plus, oh, you don't remember it? Guess what? Look back at your notes. It's right there. D times n minus 1. Now that's the general form. For this particular sequence, we need to fill in the information we know. A sub n we don't know. That's what you would be trying to find. But we do know a sub 1. It's 100. And we do know our d. It's negative 17 times n minus 1. There's your formula. Okay? What's the 34th term? Then we're going to plug 34 in for our n's. So the 34th term would be 100 plus negative 17 times n minus 1. If 34 is n minus 1 is 33. Calculate that. Whoops. And I get negative 461. How's that negative when these numbers are positive? Well, keep in mind you're subtracting numbers each time. So once you get to the 34th term, yeah, you're definitely going to be in the negatives. What's that graph going to look like? Well, I know that it's arithmetic, so therefore I know it's linear. And I know that I'm starting with bigger numbers and getting smaller, so I know I have a negative slope. I also know I have a negative slope because I am, my common difference is a negative number. So it will be a linear graph with a negative slope. Specifically, that negative slope. I don't want to use that number because I'm not counting it. So we'll just say, whoops, that's fine. It will be a linear graph with a negative slope. Consider the following graph as a sequence plotted by n and b sub n, or b of n. Is it arithmetic or geometric? Well, arithmetic's linear, geometric is exponential. This is not a straight line, so it cannot be arithmetic. The sequence is geometric because it forms an exponential curve. What is the explicit formula for the sequence? So now we have to think of our general form for a geometric. So a sub n, oh, you don't remember it, guess what? You have notes, go back and look at it. A sub n equals a sub 1 times r to the n minus 1. That's the general form, plug in what we know. A sub n equals, well, a sub 1, your first term, look at here, you're not counting by 2's, you're actually counting by 1's, you're just labeling every second, but that's in the middle, so 1/2. Times, okay, well now we got to find our r. So if we started with 1/2, then our next term was 1, and then our next term was 2, and then our next term was 4, and then 8. So what are you doing each time? What are you multiplying by to get the next term? You're multiplying by 2. So 2 to the n minus 1. That is your explicit formula for this particular sequence. Keep in mind, don't think, if you were trying to simplify this, don't think that you can multiply this stuff first. Order of operations is going to tell you that you have to do the exponent on here before you do the multiplication. Your calculator, if you're plugging the whole thing in, will do it for you. Just don't try to do part of it first and get a little bit messed up there. All right, pause the video and try this one on your own. Okay, compare your answers to my answers. It's geometric because you're multiplying by a constant, specifically 4 each time. So there's our formula. Keep in mind, again, one more time, this is not the same thing as 20 to the n minus 1. You cannot do that multiplication until you would do the exponents. So as far as simplifying this, we cannot simplify that any further until we go to plug an n in, until you're asked to solve for a particular term. The graph will be exponential. We know geometric sequences always form exponential curves. And this one you are increasing, so I said it goes up. Okay, good luck on the rest of your packet.